Hello everyone. So I am back with another devlog about my Unity project where I am training an AI to dodge bullets using reinforcement learning. The eventual goal of this project is to build a symmetrical 1v1 game where an AI and a human player try to shoot each other and dodge their opponent's bullets. In this devlog, I'm going to talk about the upgrades I made to my game by making the training environment harder, the abilities I added to the player to let it survive the spike in difficulty, and also about the issues I faced while training with ML agents in this new, more complex physics-based environment that involves multiple game objects, coroutines, and callbacks, and how I had to solve these problems with a massive refactor that enabled me to properly train an RL agent model at extremely high timescales without any loss of efficiency. But before that, let me give you more background first. Since Devlog 1, I have updated the environment by letting the bullet spawner fire bullets from a wider range of heights. I did this because the final 1v1 game should allow players to fire bullets mid-air, and so this training environment needs to be as close to the final game's environment and dynamics as possible. I also introduced a ducking mechanic to let the players crouch underneath high bullets, and to avoid situations like this where you can't jump nor duck, I added a dash mechanic that provides the player with invulnerability frames. It's basically a get out of jail free card that disables collision checks between the player and all the bullets when the effect is active. I also added a cooldown to the dash ability so that the player can't spam the dash button forever and try to game the game. With these changes into the environment, I started training with the usual time scale of 10 in 8 parallel environments, and I saw that it was getting good, like really good. But then when I used the model to check in the editor after it finished training, I saw that it sucks. It seems to have not learned anything. It struggles to even jump. Something about the timescale mismatch during training and inference might have caused things to break. To prove this, I trained another model with a timescale of 1, and I saw that the trained model indeed performs just as well during inference in the editor as it did during training. The only issue with training with a smaller timescale of 1 is that it takes about 10 times longer to train a model, even with multiple parallel environments. I was pretty confused with all of this because I thought I followed all the guidelines from the docs. I had all of the environment dynamics code in the fixed update function, and I also was using wait for seconds for all my coroutine delays, which operated on scale time, unlike wait for seconds real time, which operates on unscaled time. I found that other people have been having similar issues in complex environments that rely on a bunch of coroutines and callbacks. Now, I am no expert on how coroutines work, but I got suspicious.
Fine. I'll do it myself.
So, I made a new class that replaces the concept of a coroutine that operates entirely on physics time steps. The code is pretty straightforward. It inherits from the monobehavior class, accepts a callable function and the wait time as a float input, and in the fixed update function, it keeps track of the time passed since it was initialized in terms of fixed delta time and executes the callable once it finished the input wait time. Of course, since my game needs to create a bunch of coroutines which often run concurrently, it is inefficient to keep attaching and removing these components onto the character. To address this, I created another manager script that contains a high-level dictionary data structure that stores key value pairs between specific behaviors represented as strings and those wait for fixed time objects. This functions as a form of object pooling that lets me initialize a specific coroutine for a specific task and just lets me reuse it throughout the game, just disabling and re-enabling them without needing to attach and detach them at every time step. I also added a function that allows me to finish all existing coroutines in the same time step or abandon them and leave them dangling without having it to finish its wait time. And it is pretty useful in many cases in the code, especially during resetting the environment after the last episode has finished and a new episode is about to start. Oh, and by the way, I am brand new to YouTube, so I appreciate you checking out my videos. If you like them and want to see more, please subscribe to the channel. It's gonna make my day. If you want, please leave a like and share it within your community. It really helps the algorithm recommend my content to a wider audience. Thank you. Anyway, so after finishing the new fixed time based coroutine class, I simply replaced wherever I call start coroutine, call my custom function instead. And voila, it all works. And after I trained the first model, I can see that the same performance in the editor at timescale 1 as it was during training, which was at timescale 10. Nice. Now this is an open disclaimer. You may not need to implement something like this for your RL environment. I'd still suggest you to try first with the normal stuff that the Unity docs suggest and only attempt something like this if the simpler way doesn't work. So that's all I had for this devlog. I might do a future video to go into more detail about the specifics of the observation space that helps to train the model, such as calculating the time to collision with each bullet, and also unpack all the other components that make up my reward function, such as using an energy term to keep the movements feel less noisy. But in the next devlog, I'm aiming to add a bullet firing ability for the character and train a multi-agent environment where the two players compete against each other to train the final AI using a neat concept known as self-play. Stay tuned for that, it's coming pretty soon. Thank you for watching till the end. You are magnificent.